If you can't code, you can't be a data scientist. So we're going to do an Oxford-style debate. I'll just quickly describe the format. We're going to have the panelists, debaters introduce themselves. We will take a vote from the audience to start. They will each get 7 minutes aside to present their cases. You guys can ask questions to help clarify their positions and clarify your own thoughts about it. They will then have a 2-minute close, and then we'll have a closing vote, and we'll see if any minds were changed. So on that note, why don't we start with Hilary and go down on introducing yourselves.
Great. Hi, everybody. This is going to be a lot of fun, and I look forward to you changing your minds to agree with us. My name's Hilary Mason. I'm the founder of a company called Fast Forward Labs. We're an independent machine learning, machine intelligence research lab here in New York. I also work with Excel Partners as their data scientist in residence.
Hi, everybody. Great to be here. My name is Lucian, and let's see, I'm both a data scientist and an engineer by training. So worked in parallel architectures, parallel algorithms for parallel architectures, worked in natural language processing, statistical machine translation, and so on. Had a PhD and a master's from CMU. Worked in healthcare, built an active learning extraction platform, and so on and so forth. Started a company called Level Up Analytics a couple of years ago, and now I'm at Intuit, leading the data engineering for Intuit. So.
Lots of code.
Lots of code.
My name's Scott Nicholson. I am head of analytics at a quiet startup called Point. Before that, I was in healthcare. I've worked at LinkedIn. My background is I have a PhD in economics, so I kind of come at this industry from the perspective of, and I don't want to say no code, but I might say bad code, or big scripts, things like that.
My name is Joe Adler. I've been a data scientist for probably 15 years, probably longer than there's been a term data scientist. I've worked most recently at LinkedIn as a data scientist. Before that, I've been at Netflix. I worked at VeriSign for a long time. I did consulting in the financial industry way before that. I wrote the O'Reilly book on R, so I know a thing or two about writing code for data. I have a degree in computer science, and I'm going to be arguing against this proposition, so we'll see how that goes.
Okay.
You can ask the audience to vote before we start?
Yeah, so I'm going to repeat the question. If you can't code, you can't be a data scientist. So please vote.
Wait, what are people voting for?
I'm sorry, vote. Do you agree?
I thought they had we're doing,
So I think we vote first for agreeing, and then you can vote to see if you disagree with the proposition.
I thought when they were handing something out, I thought there was some better mechanism than manual counting. So if you agree with this statement, if you can't code, you can't be a data scientist. So I got 2 here. Yeah. Okay. I think I have a sense here. Okay. The opposite. That statement is BS. It's funny, you're even clustered by geography on the floor. Okay. Okay. Not a real count. We're like a Senate vote or a House vote.
Okay.
So we kind of know where it stands. It is a little pro the statement. So we're going to start the 7 minutes now. Because we don't have a timer up here, I'm just letting you guys know when there's 1 minute left, I will softly say 1 minute so that you'll know that the timer is going to go. And since you started the introductions, I'll have them go first and then come back. So start now, 7 minutes.
So we are arguing against the statement. Hopefully proving falsity is easier than proving truth. Let's start with the contrapositive here, right? So if you're a data scientist, then you can code. It's not that you have to code, it's that you can code. So really all we need to do is we need to find some examples of data scientists who don't or can't code, right? So we're going to focus on a few things, Joe and I. Joe's going to talk about tooling, but I'm going to go through, and he promises not to go on about his new tooling startup in Tirana. And so I'm going to start with 2 things, right? The first one is some thought experiments around kind of data science and coding. Right? The data science is really about extracting insights from data, like owning this end-to-end process of asking questions and taking that all the way to the point of discovery and the delivery of insight. Right? And so that does not necessarily require code. There are ways to go through that process without writing code. Right? So what if we sat someone down in front of a box, right? And it's a smart box, and that person can interact with this box by speaking, potentially by clicking, touching, something like that, but they're not actually writing code. Right? What's the difference between a data scientist going through that process and being able to do all of the things that they could do, or let's say the vast majority, and still go through that process of uncovering insights that we didn't know before we dug into a data set, right? Those are the things that really define data scientists to me. The second one is, what if we had no programming languages? Right? If there were no programming languages to begin with, but we had the ability to, say, write down data, it might be extremely hard to do the work that we do now, but it's possible. It'll just take a lot of time and a lot of effort. So we can still be good data scientists, just not efficient ones. The final point that I'll make was made on this stage, or at least the stage across town a couple of years ago by John Rouser, that there are data scientists that have existed long before code existed. Right? So there's an example of Tobias Mayer, this 18th century astronomer who was the first data scientist according to Strata, and they have published this. But that was, of course, before code.
Thank you, Scott. When we were thinking about this statement, we were thinking that if you can't code, if you can't code, you can't be a data scientist. Scott talked a little bit about what it is to be a data scientist and what data science actually is. And for us, data science was about solving problems. It's about understanding a problem in the world and being able to do the math and think through the solution to the problem. And for us, it's not about necessarily building your own tools to solve the problem. The fact is that a lot of the work that we do as data scientists today is pretty formulaic. A lot of the things we do are repetitious and are things that you do over and over again. There's a great talk a couple years ago at Strata by a guy named Jeremy Howard, who was one of the founders of, the chief scientist at Kaggle for a long time, where he talked about the two algorithms everyone needs to know to do machine learning. And he boiled it down to, I think, elastic net and random trees as being the two that you need to know. Well, you don't have to write the code to do those. You can pick off-the-shelf code to solve those problems. And right now we're living in a time when there's an explosion of tools for the person who is not a coder, for the person who does not want to write code, to do data science work, to do all these different things you need to do, to wrangle your data and get your data ready, to store your data, to ask questions about it. There's a great set of startups starting to tackle the problem of just this data wrangling and data cleaning. So companies like Trifacta and Paxata and Tamer, led by some of the greatest minds in data science. A lot of the guys out of the AMP lab at Berkeley, guys like Stonebreaker, have started companies to tackle these problems in a graphical, intuitive way without writing your own manual code. And so for us, we feel like we're living in this time where you have the ability to do that. On the visual side, there are great tools for visually exploring the data. There are tools like Tableau that are out there. There's tools like what my company makes in Tirana for looking at data without sitting and writing lots of code and building your own tools to answer questions. And so to answer valuable questions about data, our feeling is you don't need to know how to code. It's not necessary to do that. You can be a data scientist, you can discover great things, and you don't have to write your own tools to do it. I think I got about a minute left.
Yeah, that's good.
You actually have 2 minutes and 15 seconds.
Wow, that was faster than I expected this to be.
Have you run out of arguments?
You're going to need all the time.
Oh, we can keep going on this. One of the questions I have is the big questions we have is about what the line is for coding and not coding. And I think both sides are going to touch on that a lot today. And for us, there's a question about, if you're using Excel, if you're building a model in Excel, is that coding or not? There's algorithmic thinking there, but you're not typing in language for your machine to code. Is that really coding? I would say, as somebody who's worked a lot with R as an example, I feel like simply typing in commands doesn't feel like a line to coding. If I type the command read.csv to read in a CSV file, and then I type a command to fit a linear model, Did I build my own tool? Did I write code? I think that if the line is simply typing things in to use tools that already exist, you're probably not really coding. You're not building your own tools from scratch. And I think you can do a huge amount of work that way. I think simply scripting things and doing things in text rather than graphically is not the line. Was that 1 minute, or is that we're done?
You have 1 minute left now.
So that's one of the other big things that we've been thinking about. God, I really should have given myself a clock. I went much faster than I expected. For us, so in my experience, I mean, I've written huge amounts of code in my life to do data, and I think the fact that I've had to do this in the past is not a sign that this is something I'm going to have to do in the future. It's not a sign that I have to work that way. The fact that we're using a tool chain now that requires you to write code and wait for overnight for answers is not a sign the world has to be this way, that I have to actually go through lots of work to write complicated statements. It isn't necessarily a sign that this is necessary for this job, and is not the way that the world has to work.
That's right. And things that you had to do 2 years ago even, you don't have to do today, right? So you wouldn't want to go and have to build all those tools again so that you can just take advantage of that library, that API right now, which saves a lot of headache from needing to go and rewrite it all again. So why wouldn't we take advantage of these things to be more efficient, assuming they're available?
So now that they get going, their time is up. One of the things I will do is I will do a 5 minute and 6 minute and 7 minute.
Okay.
So just so that you guys have a sense of the time. It's hard for me to display this clock. I will just quickly summarize a couple of key points from my perspective. It's all about discovery. There was data science before there was language. New tools weaken the need for coding. And Excel is not coding. Does that paraphrase your main points?
Yeah.
Okay. So I will start the 7 minutes now, and I'll even put this phone here so that maybe you guys can see it as it's going.
All right, I'm going to begin for our side, just so everyone has the right context. I'm going to start with a few definitions. Just to remind you, we say that you can code, you can be a data scientist. In fact, it is a necessary skill for data scientists. But nobody here has really managed to define data science. And I'm a practicing data scientist. I've hired many. There are many sitting here at the table with me. What data scientists fundamentally do is understand a problem, go off and discover something, do an analysis, build a model through data that informs a solution to that problem, and go communicate that solution back to whoever had that problem in the first place, if it wasn't them themselves. And so you might think about what that work actually looks like. And I know we have many data scientists in the room. So what do? You think about a problem, maybe you take some notes, you do some math on the whiteboard, but then you need some data. So what do you do then? Well, where is data? Well, we did have data scientists before we had data in any sort of computational form. Data in 2014 lives in computers or in the cloud. You can tweet that, right? If you want to work with data in 2014, you must be able to interact with the systems in which data lives. And those are systems that require technology to interact with them. We also have talked about coding without really defining what that means. And when I assert that you need to code to be a productive data scientist, I'm not saying you need to be a professional software engineer pushing production code and supporting it, but rather that you need to not be scared to use tools that give you the most power that exists. And that generally means typing some commands and watching what happens. When we say code in R, that's coding. And yet we are not writing machine language. We are not actually tracking which bits live where and what's going to happen next. We don't need to do that in 2014. We have programming languages at such a high level that coding today allows us to do pretty amazing things. And so I agree with my colleagues here. Also, Excel, which people seem to think is not coding, has Visual Basic for Applications built in, which is a Turing-complete programming language. So stop being a snob about Excel. It is programming. It's coding. So now that we understand data science as the practice of using data in 2014 to come to some insight, to come to some new decision, and coding as the ability to take these extremely powerful tools, I want to address the assertion they made that you can be a good data scientist, but not an efficient one without programming. There is one word I disagree with there, which is the word good. You may be able to meet the minimum qualifications of doing data science by doing it on paper on a whiteboard today, but I would not hire you. Another discussion we've had is around the change in tools, and that tools today are much more capable than the tools we had even 4 or 5 years ago. And I know we probably have people in the room to thank for that. Thank you. Keep doing it. But if your tool is so advanced that you are able to work with your data with the full power of a programming language, you'll have to prove to me that it is not coding. A sufficiently advanced tool is indistinguishable from the capabilities of a programming language and therefore indistinguishable from coding itself. With that, Lucian, you want to take it from here?
Sure, sounds good. So let's see, I think it's a matter of framing and limitations, and we all want to automate everything, of course, yes. That's not in question here. I think in question is really, should you be able to code if you're a data scientist? And the answer is obviously yes. Data scientists really are the kind of Swiss Army knife, if you will, of this day and age. When I think of data science, I'm thinking about it bridging the gap across more traditional silos, if you will, across engineering, statistics, analytics, product. And nowadays we live in a kind of, actually we've always lived in a wonderfully messy world where there's no common single neat schema that we can all go by, right? So if you think of many different kind of views of what a data scientist does, but definitely they think a lot. We think a lot. We're faced with amorphous, ambiguous problems, and then we try very creatively to solve them, right? We actually connect to many different heterogeneous data sources. We're very creative about how we drill down into the data. We build models, we build prototypes, sometimes we even help taking them to production, and obviously we adapt and iterate. So sometimes the output of data scientist work is an insight, sometimes a prototype, sometimes it's a product, a data product. But the common thread underneath of it all is really coding. So now, take away coding from data scientists, and they will have no choice but to think and act inside the box. It may be a very nice box, beautiful, very useful box, but it's still a box. So, recently, in the grand scheme of things, we kind of moved away from a waterfall world, and we don't want to go back. And what I mean by that is, without coding, we would have the antithesis of agile, and progress in innovation would be slow. And if we don't have coding, programming, we would be very limited.
1 minute left.
And thank you. And dependent on others to get the inputs, to get the data, and we'd be very limited in the outputs that we produce. And one assertion would be that coding is really the new literacy for all fields in science and engineering, and data science is definitely up there. The genie's out of the bottle, and it's not going to go back in. Thank you.
These guys are so efficient, they all ended before their time. Any other quick thoughts? Okay, well. So I will quickly summarize that data science is about defining the problem and resolving, communicating it. And since we're in 2014, that means using computers. And that means knowing how to code. That pretty much if you're typing, you're coding. That it's an iterative process, and iteration is something that's very common to coding. And so it's like the warp and woof of coding. And that there's some, and I don't know if I got this fully, some relationship between coding and agile development, the modern way of doing things, that you might not be able to capture otherwise. Is that fair? And I also want to address one point. If we look in the audience, we'll see a lot of Macs. There's no VBA for Excel on a Mac. Just for...
You're supposed to be neutral, Roger.
I'm just the facts. Okay, so now it is time for questions from from the audience. And really that Excel one was the one that we thought we should, and it's kind of up to you to decide how much of Excel is coding and how much of it is not. Now, we have 2 microphones, as you can see, so if you have a question for this esteemed crowd, well, you're not really a crowd, but
no, nor are we esteemed.
Yeah, esteemed team. Please on the left, and then we'll alternate.
Nice alliteration, esteemed team, and so on. So part of the skills of the programmer are essentially mathematical. The other part is this habit of efficient indexing, efficient representation of data, variable allocation. Here is a question, and I'm not sure which point it proves better. If you take away this skill of indexing, this ability to write certain algorithms, and just leave the mathematics, is the person still a programmer, and is he still a data scientist?
So we'll start with you guys and then go there, and I'll just keep switching who starts.
I'd say certainly in the sense that I know people, data scientists who code, who confine their coding activities largely to statistics or to doing exploration of data and not to building production infrastructure around data. They are still coding, they are still data scientists.
Yeah, I would say the same thing. I think if you think about it, if you don't do loop unrolling, you can still be coding, right? And you don't have to go necessarily to that level of detail. Now, is it useful to know how to deal with skew in the data? Absolutely. But sometimes you don't have to build those primitives. Sometimes they're there for you.
Okay.
I think I got to take the no point on this. That the data science is about understanding the problem. It's about understanding the world. It's about being able to look at, to absorb what that, to create this model of the world and understand how things work. And I don't think it's necessarily. I think the skill to translate that into computer language, to translate that process there, isn't the necessary component. I think you can ask questions without doing that. I'll pick as an example. One of the greatest data scientists I know is a woman named Monica Rogati, who's famous for saying that her favorite algorithm is division. And I think that you don't necessarily have to know that much code to divide things. I can do that with pencil and paper, and I would argue that if I'm just doing something like division, if I'm using a tool off the shelf to do that, it's not coding, and that's a great way to understand and represent a problem and be a data scientist.
Can I talk to him?
You can, yeah, this is debate. You can debate.
So you've just redefined coding that you seem to think is like not novel. You're programming something that is a well-understood algorithm is not coding.
I see it as building a tool rather than using a tool. I think that simply crossing the line, if we define coding as using a command line, when I type ls on a Unix prompt, am I coding? I don't think I'm coding. In the same way, if I'm writing in R and I'm just typing a command, is that coding? I don't think that simply saying use this library, use this tool this other person has built, load this data into a data frame and then create a regression model with it is coding. I feel like there's a line there where the line there is whether you're actually constructing your own tool and defining the process and telling the computer the detailed process.
I disagree. I find the line around coding is when you type code. And ls in bash is coding, yes.
Okay, so we'll go to the next question on the right.
Hi. So a lot of good coverage in terms of getting to the right data, density-wise, variable data-wise, and also a lot of good coverage in terms of operationalizing your model. Now, my question is, I have a business problem in front of me, and I want my data scientists to tackle it. I have 2 different types of data scientists. One, a data engineer, a coder, turned as a data scientist. He grew himself into it, he or she. And the other one is, from inception, the person is a data scientist and had to learn a little bit of coding to operationalize or to get through the day-to-day activities, but by approach, he's a hardcore data scientist. Now, can you all please explain me who will be approaching the problem, in what way, and what is the most desirable outcome from your perspective?
Team no code. You guys.
I could take this to start with. So. There's a really good question here about where is this line, because in a larger organization, in a very small company, if you're just a single person who does everything, you might be you actually might be writing some code, you might be analyzing some data, you might be going and talking to investors and doing lots of other things. In a larger organization, people are specialized, and there are people who do have different roles. And I think it's a good question. On a larger team, there might be people who are implementing a production model and taking some math and some predictive model and making it scale, or creating a data pipeline that takes data from some set of production services and puts it into a data store where it can be analyzed. And it's a good question, but which of those roles is a data scientist and which is not? And I would assert that if you say anybody who has to touch data, if you would argue that everybody who touches data in any way is a data scientist, unfortunately you could extend that argument and say, well, anybody in any organization is a data scientist. That product manager who analyzes the growth rate of his product becomes a data scientist. That engineer who's writing the front end JavaScript code that users are going to interact with, that will then generate data downstream, ends up being a data scientist. And I feel like this argument gets stretched too far. So from my perspective, the data scientist is the guy who actually solves the problem, who defines what the problem is that you're solving and understands it, not necessarily the person who's building the production system or building that data pipeline that moves data around the organization, or building the tools to solve the problem.
Just add a quick point. I think some of the definitions of data scientists out there involve the concept of a hacker, right? Like being able to efficiently get to an endpoint as quickly as possible using whatever tools you have available. So if you have data scientists who are maybe on the other side of data engineering, right, these people are going to be really good at understanding, where they need to go, and what the questions are, and then who they need to talk to in order to get the information that they need. Not necessarily the ones who are going to go out and build the infrastructure in order to solve the problem. Right, and so if I've got the opportunity to code in front of me to get something done, I can do that. If I've invested in a tool that's going to allow me to do this without writing any code, I'm going to do that. But coding is a means to an end, right? But that's what it is. Or you're trying to get somewhere else, and coding is not necessarily the way to get there.
Okay. Team code.
Can I take this?
Please.
All right, so let's analyze a little bit the workflow, right? So in the spirit of this debate, essentially we have the gal or guy who doesn't code, but can think really well and use some tools, right? So the workflow would be like this. Here's the problem. Let me think about it. I think I can use these tools, maybe do some preliminary analysis, but wait, there's a third-party data set that, here's an API. Hey, Mr. Engineer or Miss Engineer, can I get, can you give me the data? So waterfall already. Then there's feedback loop. Here's the data set. Actually, after some very limited analysis that you can do with tools, can you please go get me some more data? And after a series of probably email exchanges and things like that, finally we come up with the solution. And then can you guys, some other team there, and you don't know what's in my head, but please build it for me. So
do we want to make research time-bound?
I'm sorry?
Do we want to make research time-bound?
That's another debate.
That's another debate, right? And do you hire research scientists who tweak a model between 92 and 93%, or do you get data scientists who get you from 0 to 60, right? But the alternative is the two people you mentioned, the data engineer turned data scientist, and then the data scientist who can code. Why don't they work together, figure out the problem, figure out the data that they need, pull it, build a solution, and possibly even help take it to production?
If I can add one quick thought as well, in your initial question, you spoke about one person as the hardcore data scientist and one person as the engineer. I actually think that word hardcore is sort of a dangerous distinction to draw between one person who may have come perhaps from a statistics background or a science background and learned to program versus someone who comes from a programming engineering background and learned statistics. There really is there's no, this data scientist is better than that one. It's just that within the portfolio of skills a data scientist can have, which are things like math, statistics, programming and technical infrastructure design, and then communication, visualization, design, whatever that might be. Everyone sort of has different skill levels within those things, and no set of those is better than another set. So when you pose the question, it's really about figuring out what is the quickest way to the solution through the skill sets of the people
what is the
have.
best approach, like thinking process? How do you attack the problem? How do you solve the problem?
I'm just going to cut it off just because we're running out of time, and I'd like to get one more question in. Like they say, time flies like an arrow, and fruit flies like a banana. Slow time.
All right, so a common and recurring theme amongst data scientists, statisticians, and scientists generally is the issue of reproducible research. And the ability to code is not necessarily the foolproof way of solving that, but it certainly helps when someone can see exactly the sequence of steps that you've taken when you've cleaned a data set or analyzed it. So this question is primarily for team no, you don't have to code. In the case or team no code. If how do we go about solving the reproducibility problem without being able to track exactly what someone has done in analyzing a data set?
So I don't. If the whole goal is to track what somebody has done, there are different ways to do this. I mean, the most ridiculous version would be set up a video camera over your shoulder that watches what you're doing with your computer so that somebody can go and replay it later. There are all kinds of techniques that do that. I hate to go and talk about my own product. We do this in software. We actually show a set of breadcrumbs that show your analysis path as you've gone through it in a way that you can replay it and go back, pop an item off the stack, and look at a piece of analysis you've done in the past. I think, as you've said, coding could make that more convenient. It's nice to have a nice script that somebody could rerun to recreate what you've done, but there are many techniques for doing this. I mean, even people who code all the time and know coding tools know that to do things like test a user interface, you want to script that. You can create. There's definitely software that helps you solve that problem that will record the set of actions you've taken and allow you to play them back later. So I'm not sure that certainly reproducibility can be much more elegant with code, but I don't think that means you can't do it.
Do we have time for one more?
I'll take one more. Everyone's going to have to be really fast because we're really getting with little time for our votes.
Lucian, I liked your Pearl-esque analogy about the Swiss Army knife, by the way. Scott, my contention with your assertions is simply the absence of said box and the presence of said languages, right? Reflecting reality, we have those things today. And then the tangential question that I have for all of you, I teach people how to code in Python and R, and I think learning how to code makes you an exponentially more productive data scientist. So would you at least agree that the whole practice of learning how to code teaches people how to think more logically and address problems more effectively?
Let me just respond directly. We don't have that box today, but what I think the yes code side is thinking is that the only way to solve problems is with code, right? And what we're saying is that there are solutions out there that can get you very far in the world of data science and handle 80% of the work that we do, right? We're not always building infrastructure. We're not always going from 92 to 93%. 80% of the work that we do is data munging, data pipelines, histograms, looking at data, right? There are lots of tools out there that do that, and there's a lot of innovation in that space. And so I think that box is kind of slowly materializing. In the future, right, we'll have it, but right now we have some version of it that can cover some of the field.
Just a clarification, we're not saying that without code you cannot solve problems. Far from it. In fact, you can automate a lot of those things. We're saying that you cannot be a data scientist without knowing how to code.
Yeah, on that note, because of time, unfortunately, we're going to have to stop. And now it's time for your 2 minutes. And I might do moderator's call and say a minute 30 because you both went short. So, and we'll go the opposite. We'll have the other team start first. So you get to go first. And 3, 2, 1.
Great. So in this conversation, we've talked a lot about what it means to be a data scientist, what it means to code, and the line between doing things that are, a creative analysis where you are using code as a tool to access, understand, and model your data, and what the implications of that are. And I would agree with our last commenter that programming is empowering no matter what you apply it to, but it is a necessary power for a data scientist, especially given the state of the data that we work with today.
I feel I'm disrespectful if I sit down, so let me just do this. All right, so very quickly, I want to take it back to hiring. Hilary started this thread. So when you're thinking, whatever your philosophical stance is, whenever you're thinking about hiring a data scientist for your team, what are you going to do? Are you going to get the person who cannot code or the person who can code? You probably do not. The reality is that you do not want the person who depends on engineering nonstop, support nonstop. Engineers are already taxed and oversubscribed. You want somebody who who can get access to their own data, be super creative, go crazy with awesome data processing and drill downs, and do that without much hand-holding. You want somebody who can extract insights from data but doesn't stop there. They can take it, build some models, build a prototype, work side by side with engineers to take it to production, and so on and so forth. We want somebody who's able to write some optimization algorithms, some models, but with scalability in mind, and maybe even package in a nice library so we can use the hell out of it. And one more thing, I think coding is the great enabler, and without it, data scientists would not be data scientists.
I'm going to add one quick thought to that, which is also that in 2014, the coding tools we have are fantastic, and it is not so hard to learn to use them, in that if you are able to be a data scientist, but there's something standing in the way of your ability to code, that's an excuse, and you can learn to do it.
Okay, to be fair, it will be 2 minutes. Okay.
Sorry.
Okay, I think I'll probably start the summary with a new point, and it's just as by example, right? I think a lot of people are familiar with the Insight Data Fellows program. Right? This is a way to train top-tier PhD students to become data scientists, and it's a 6-week-long program. Right? You can't teach someone to code in 6 weeks. Right? These people who show up to the program, right, they have great intuition for data. They've solved a very hard problem in a super specialized vertical, but they haven't necessarily been learning how to be a software engineer or great data science from the perspective of coding. At the same time, these people are hired by the companies out there that have the top data science teams. Right? So there's definitely an acknowledgement that you can do great data science work and not necessarily be a coder.
I just want to say that I think that I could keep my calendar on a daily basis in a SQL database and write SQL queries to ask where I need to be, but I don't do that because I have a smartphone and I can look on my phone or I can look in Google Calendar to see what I'm going to do. It would be crazy for me to keep in the SQL database. And I think in the same way, there's a huge number of data questions that are like that. That yes, you could write code to answer those questions, but there are terrific tools that you can get off the shelf to answer them. As I said before, there's a whole bunch of great visualization tools. There's ClickView, there's Tableau to do visualization. There are great tools for querying data right now. There's whole products you can get like Mixpanel, there's Keen.io, there's a whole lot of startups out there that let you build your whole data pipeline and just put a little bit of JavaScript on the front of your product and not have to deal with any of this coding or data pipeline or answering questions, and be a data scientist and answer questions and understand how your business is running. So from my view, it's not necessary. You can be a data scientist. You can understand problems. You can solve those problems without writing code and building your own tools.
And that's perfect timing, by the way. So now for our final vote with our little drum roll and so forth. So we will start with, since the last time we kind of said team code to start, we'll say, how many people are for team no code? Okay, how many people are team code? Okay, woo! Team code has definitely convinced a few folks, a statistically valid number of folks, of their position. I'll just end up one. I want to thank everyone for the good-natured debate. Team no code, you should have brought up that you can bring more people into the field.
I was thinking about that.
You should have had him on your team.
Thank you, everyone, for participating. Sorry to have more questions.
Thanks, Roger.
I think people will be hanging around a little if they have questions you want to come up and ask.